Welcome back, everybody. This is going to be our homework review for Lesson 31, Area of a Circle. And main thing about area of a circle, we know it's the formula for area of a circle is going to be area of a circle equals pi times the radius squared. And so one of the things I want to focus on in finding the area of a circle is going to be the radius. If we know the radius of a circle, then we know how to find the area. So let's keep that in mind as a main focus for a lot of the problems we have. Before we begin, I ask that you, if you can, please leave a like for this video, and if you have any questions or comments, please leave them in the comment section below. So let's start with question number 1. If a circle has a circumference of 10 pi inches, then which of the following represents the area of the same circle in square inches? Let's take a look at the formula for circumference of a circle. So for circumference of a circle is given to us as circumference equals 2 times pi times r. And so we also know that this value is 10 pi. We said that the goal is to get the radius by itself. So if we divide both sides by 2 pi to find r, we're going to get the radius equal to 5. Well, since our area is equal to pi times the radius squared, that's pi times 5 squared, which is equal to 25 pi. Okay? And so that's choice number 3. Let's take a look at the next question. Number 2. In the design shown below, there are 4 semicircles attached to a square whose area is 36 square centimeters. Which of the following is closest to the area of the shaded semicircles measured in square centimeters? Well, I mean, although a diagram may not look exactly like it though, those 4 semicircles are going to be exactly the same size and shape. Therefore, we actually have 2 full circles. Not only 2 full circles, 2 full congruent circles. So I'll just put that congruent symbol in there. And so now the key thing here is going to be to find the radius of this circle. Well, we know if the area of the square is equal to the side squared, sorry, my handwriting's terrible, the side squared, we know that the side squared equals 36 because they tell us that the area of the square is 36 square centimeters. That means the side is equal to 6 centimeters. So therefore, this is going to measure to be 6. But that would not be the radius. That would be diameter. Therefore, our radius will be 3 centimeters. Okay, so now we know the area of a circle is going to be pi times the radius squared, or in this case, pi times 3 squared. That's equal to 9 pi. That would be the area of one whole circle. But we have, again, 2 full circles. So therefore, 2 times 9 pi is equal to 18 pi. Now, in approximation-wise, we would say in this case that pi is about 3, but a little less than 3. So if we did 3 times 18, that would be about 54. So we're going to estimate in this case, maybe the choice would be 57. But let's take a look at our calculator and calculate this. So we want to find, we said really it's 18 pi, so it's 18 pi, which is second, I guess, caret. So 18 pi gives us about 56.548. Rounded to the nearest integer is going to be 57 centimeters squared, and therefore choice 1. Okay, but if you have multiple choice and we don't really have a calculator in front of us, you can approximate pi to be 3, but know that you're underestimating it though, because pi is going to be approximately 3.14 with a little more afterwards. So you know that in this case, 3 times 18 is going to be 54. So we're looking for a number that's a little more 54. Okay, so that's going to be question number 2. Again, the goal is to find the radius of a circle. Question number 3. Which of the following formulas gives the area of a circle in terms of the circle's radius r and circumference c? So let us now again go back to our circumference formula. C equals to 2 pi r. And we want it to look like area is equal to pi r squared. Well, that means in this case, we want to do in our first equation is to get r by itself. Okay? Again, give the area of a circle in terms of the circle's radius and circumference. Well, and of course, there'll be pi involved. So we're going to divide everything here by 2 pi. Well, okay, so we get the radius, all right? Or, so we would normally have the radius be circumference over 2 pi. So that's one way to look at this, though. And we can replace that r into area. Well, that would just be in terms of circumference, though. All right, so now in this case, well, let's see. Maybe this may be the wrong way to look at this. Maybe we should instead look another way. How can we adjust? So I'm going to erase this stuff here. So I'm going to try something a little bit different, though. All right. How can we make 2 pi r look like, in this case, the area pi r squared? Well, let's see now. Well, I think in this case, I'm going to divide both sides by 2. I think this is the best way to approach this, ladies and gentlemen. We want to convert 2 pi r to look like pi r squared. So we'll divide both sides by 2. And so now we have pi r on the right side equals circumference over 2. Okay, so now in this case, oh, sorry, we don't have pi r squared. We just pi r. Now in this case, we're going to multiply both sides by r, because again, we want pi r squared. Again, we divide both sides by 2. 2 is divided by pi r on the right side. And then we have the circumference over 2. And now what we want to do is we want to multiply both sides of the equation by r. And so therefore, we're going to get pi r squared, which is our area formula. And this is going to be 1/2 times circumference times the radius. Okay, 1/2 times circumference times the radius. I'll use this instead of x's and also. So now we have taken our formula. At first I was isolating r by itself and maybe finding the area in terms of just circumference, but they wanted the radius and circumference. So it looks like we're just going to see what we can do to change both sides of the equation for formula for circumference into make it look like pi r squared. Okay, so the first thing we did was divide both sides by 2 to get pi r equals circumference over 2. Multiply both sides by the radius to get pi r squared on the right side, which is the area we're looking for. So in this case, our area will equal to 1/2 times circumference times the radius. And that looks like, in this case, choice 4. Okay? All right. So that was kind of theoretical, kind of weird and all, and I got kind of thrown a little bit myself as well too, but we see in this case how we change one formula and transform it to another one. Okay, next question. Question 4. Now, this little piece here, which is really going to be the area that is enclosed by a chord and a arc of a circle, is known as a circular segment. So this is really known as a circular segment. Type that in here. Okay, and I had to look it up as well too. So just to make sure. Oops, just make sure I got the right font. So here we go. Circular segment. Circular segment. Why is it? Oh, there it goes. Okay, and that's the area. That's not, when you hear this, you think like it's an area, circular segment is a piece. No, it's not an arc. Circular segment is going to be the area here. So here, that's this here. Okay, this whole blue section, if you will. And so now we're told in this case that an isosceles right triangle whose legs are 8 inches each. So we know this is going to be 8, and this is 8. 8 inches and 8 inches. And we see that this triangle, the two legs of the triangle, kind of form a quarter circle, if you will, because it's an isosceles right triangle. So the central angle is 90 degrees. So what we really have is a quarter circle. A quarter circle. So area of a quarter circle is really going to be pi times the radius squared times 1/4. So our whole section, if you will, it will basically be taking this entire area here, All right, we'll find that area first. And then we're going to take away from that minus the area of the isosceles triangle, which is 1/2 base times height. And so we're going to do the following for the quarter circle. We're going to find, in this case, 1/4 times pi times 8 squared, because that's the radius, 8 squared. Then we're going to subtract from it 1/2 times 8 times 8. Well, just to simplify things a little bit, 8 squared is 64, and 1/4 of 64 is going to be, I believe in this case, 1/4 of 64. So 64 divided by 4, that's going to be, I believe it's 16. Yep, I think so. All right. So we have 16 pi, and then 64 divided by 2 is going to be 32. So now this would be the exact value as far as square inches, but we're going to take our calculator to find this. So now we'll do 16 pi, second pi, minus 32. And so as a decimal value, 18.265, well, approximately 18.3. So approximately 18.3 square inches. And that's going to be, in this case, choice 2. Okay? And so what we want to do is, we want to basically do is a shaded region problem. It is the big area, that red section, minus the small area of the triangle. And therefore, the leftover part is our circular segment, which is, again, it's area, not an actual segment, though. All right, ladies and gentlemen, this is going to be the end of part 1 of our review for area circles for lesson 31. Please make sure you catch part 2 of this section, where we start going into more stranger shapes, and just in this case, it gets a little more detailed, if you will. Thanks for watching. I appreciate it. Please, again, make sure you give a like to the video, and leave a question, comments below. If there are any other topics you'd like to cover or things to go back to, please let me know. I most definitely will try to make a video for that as well, too. Thank you so much again, and take care. Be safe. See you in the next video.